Hello guys, this video is about mechanics of a single particle. In this video, we are going to discuss about linear momentum, angular momentum and torque. So, first of all, we should start with linear momentum. Linear momentum is denoted by the letter P and it can be defined as the product of mass and velocity. Let us consider an object moving with a velocity v and having mass m. Linear momentum of that object will be the product of the mass and its velocity. So, its equation can be denoted by P equal to m into v. The SI unit of linear momentum can be told as kilogram meter per second. SI unit of mass is kilogram and velocity is meter per second. Now we are going to discuss about the properties of linear momentum. Linear momentum is a vector quantity pointing in the same direction as velocity. The rate of change of linear momentum of a particle is equal to the net force acting on it. F is equal to dp by dt. From this equation, we are deriving the equation for force F is equal to ma in Newton's second law of motion. This is the next property which says that in an isolated system with no external force, the total linear momentum is conserved. This can be told as the law of conservation of linear momentum. That's all about linear momentum, and now we are moving to angular momentum. Angular momentum is denoted by the letter L. Let us consider an object moving in a circular path or exhibiting circular motion with a velocity v, and this force will be centripetal force because it is traveling in a circular path. The angular momentum can be told as L is equal to mvr, mv equal to a linear momentum, so L is equal to r cross p. It can be defined as the cross product of linear momentum p and the position vector r. So, from this equation r mvr, we know that angular velocity is omega is equal to v by r. If we substitute the equation for v from this equation, L becomes L m r omega r, that is L equal to m r square omega. We also know that moment of inertia I is equal to mr square. So we get the equation L is equal to I omega. This is the next equation for angular momentum. So from this equation we can define angular momentum as the product of its moment of inertia and its angular velocity. The SI unit for angular momentum is kilogram meter square per second. And now we are going to the properties of angular momentum. Angular momentum is a vector quantity which is perpendicular to both position vector r and the linear momentum p. The rate of change of angular momentum is equal to the torque acting on it. As in linear momentum, it is force, and in angular momentum, it will be torque. The next property is, in absence of external torque, the angular momentum of a system is conserved. So this is the law of conservation of angular momentum. In linear momentum, if there is no external force, the linear momentum of a system is conserved. Like that, in circular motion, torque is the force acting. So, in the absence of external force, the angular momentum of a system is conserved. Now, let us discuss about torque. It is denoted by the letter tau. Simply, torque is the rotational analog of force or cross product of force and position vector from the point of rotation to the point where force is applied. So, torque can be the cross product of force and the position vector from the point of rotation to the point where force is applied. That is, torque tau is equal to r cross f. It can be defined as the magnitude of the torque will be rf sine theta. SI unit of torque is set by Newton meter. Now we are going to the properties of torque. Torque is a vector quantity which is perpendicular to the plane formed by R and F. Torque can also be given as tau is equal to I alpha, in which I is moment of inertia of that particle and alpha is angular acceleration. So let us discuss about the summary of the video. In this video, we have discussed about linear momentum, angular momentum and torque. The equation for linear momentum that we found was P equal to mv. The equation for angular momentum L equal to R cross P and torque tau equal to R cross F. Thank you for watching this video.